Hi guys, it's Mrs. Tucker. Okay, we're still working on computation tests, the notes for our journal. So you've got some examples to go off of. All right, number 6 on the computation test is always long division. And this is where kids mess up all the time. I guess math teachers have just been teaching this wrong. Shame on us. All right, so we're going to I'll do the best I can to give you some ideas on where to go with this. All right. Number 6 says, if necessary, round to the hundredths place. So I've got 3.224 divided by 0.07. And before I start, I want to estimate what my answer is. Okay? So forget about this problem for a minute. Take a look at what I've got going here. Help me work these out. What's 24 divided by 4? Yep, the answer's 6. What's 24 divided by 3? Okay. What's 24 divided by 2? What's 24 divided by 1? What's 24 divided by 0? Yeah, that one's special. Why is that one special? You can't divide by 0. That's right. Okay, now I want you to take a look at this. The 24 always stays the same, but the number that you're dividing by keeps getting what here? Yeah, it keeps getting smaller and smaller and smaller. And as our divisor, that's called a divisor, as our divisor keeps getting smaller and smaller and smaller, what is happening with our quotients? It's getting bigger and bigger and bigger and bigger. Of course, we have to skip this one. Okay, we have to skip that one because you can't do it. What do you predict is going to happen when I take 24 and divide by 0.1? What do you think is going to happen? Take a look at these answers. Bigger, 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 bigger. We're going to have to jump over this one. What do you think happens right here? I'm thinking it probably should get bigger. Okay? So let's take 24 and divide it by 0.1. Big mistake kids make on this one is putting the wrong number in the house. I don't know why everyone seems to think the biggest number goes in the house, and that's not always true. Okay? So when I divide, before I can start, I want to make this a whole number. And basically what I'm doing is multiplying it by 10. If I wrote this as a fraction, like this, and I multiply by 1, I still get that number. Well, what if I multiply it by 10 over 10? 10 over 10 is 1. So I'm still multiplying by 1. But when I multiply by 10, that makes this number down here 1 instead of 0.1. Of course, that makes this up here 240. So that's why we do this. We scoot the decimal place over once here. My decimal place is right there, scooted over once. And I put that decimal point right up here on the line. Okay, and I made it big so I don't lose it. Put a 0 right there. Okay, how many times does 1, we've just got one whole here now, let's get rid of this. How many times does 1 divide into 240? Yeah, 240 times. So the answer here is what? Yeah, it's 240. Okay, now, if we divided by 0.05, tell me something you know to be true about the answer. Yeah, it's going to be less than 240, but bigger than 24. Okay? All right? So, give me an estimate before we do this common error. Give me an estimate to put in my bubble when I take 3.224 and divide it by 0.07. Give me some kind of estimate. I know for sure the answer has to be what compared to 3.224? It's going to be bigger. I don't know, let's call it 50. I don't really know what it's going to be. I just know it has to be bigger. So that way when I get my answer, if my answer's smaller, I know I've made a mistake. Okay, common error. Take a look at this. We see this every year. What's wrong with this? Yeah, they put the wrong number in the house. 3.224 is being divided up into pieces, okay? The number that's being divided into pieces, and I don't care if it's a big number or if it's smaller than the other number, the one that comes first always goes in the house. All right? Common error. Okay, so let's straighten that out. We're going to put 0.07 out here because 3.224 is what's being divided into pieces. Okay? Now, the next thing we have to deal with is this decimal point out here. You remember in that example we multiplied by 10 over 10? Well, in this example, I'm going to multiply by 100 over 100 because when you multiply by 100, it moves your decimal point 2 places to the left, or to the right. That's why we do it. But I'm also going to have to do what here? Yeah, move that decimal point 2 places to the right, so it falls right there. And I want to see you guys do this because I see a lot of kids put the decimal point in the wrong place up here on the line and get all the numbers right, but the decimal point's in the wrong place. And you know how you would avoid doing that? Is if you draw in these columns. That's what my smart kids do. They get a piece of graph paper, they turn their notebook paper sideways, or they just draw in the columns and keep everything lined up. Okay? Okay, so let's start dividing. 7 doesn't divide into 3. How many times does 7 go into 32? Yeah, it goes in there 4 times. See, I'm keeping everything nice and lined up. 7 times 4 is 28. Subtract. Okay, I'm going to have to borrow. All right. Now, smart people put in those little arrows and the lines so they know where they're at. Let's bring down the 2. 7 goes into 42 how many times? Yeah, 6 times. 6 times 7 is 42. Subtract. We get 0. I have to bring this down. Okay? Bring down the 4. How many times does 7 go into 4? Well, it doesn't. You have to put the 0 there. You have to. It's a must. 0 times 7. Subtract, and we get 4. Okay? Now, we're not done. Come back up here. It says round to the hundredths place. Do you know where the hundredths place is at? Do you remember where the hundredths place is at? Okay, forgot I had this here. All right, the hundredths place. A lot of kids forget this is a rounding problem. Not only do you have to divide, you have to know how to round. Where is the hundredths place? Well, hopefully you guys have something that looks something like this in your journal now. Here's my decimal point. The 4 is in the tenths place. The 9 is in the hundredths place. But when you're dividing like this, to decide if this 9 stays a 9 or becomes one bigger, you have to take your answer out one more decimal place. We've got to see what number's in the thousandths place to see if that's going to make the guy in the hundredths place round. Okay? So we're not done. We're only in the tenths place. What do I have to do? There's the hundredths place. There's the thousandths place. So take your place here that they want you to round to and add one more place value to it. All right? In this case, we're getting one more place value smaller. All right, here we go. Still dividing. 7 goes into 40. Let's see. Let's put it 5 times. That's 35. Subtract and you get what? One more time. I got to see what number is in that thousandths place. 7 goes into 50 how many times? Yep. 7 times 7 is 49. When you subtract, you get 1. Okay. Now, it says round to the hundredths place. I've got a 5 in the hundredths place, but I have a 7 in the thousandths place. Does this 5 stay a 5? No, the 7's going to make it round up to a 6. So our final answer is 46.06. 0, 6. Circle, box, or highlight. Okay, problem number 7 is always going to be long division again, but instead of having a decimal part as a remainder, we're going to leave our fraction as a remainder. Leave remainder as a fraction. Okay? Common error. What is the common error here? Yeah, they leave it as a decimal and not a fraction. If you leave it as a decimal, I'm going to mark it wrong. Okay, so all of my smart kids do what? Yeah, they line it up, keep everything in a column, and let's just start dividing. 44 does not divide into 3. 44 does not divide into 35. I'm going to have to go all the way out here. Okay, and I know some of you guys do this. If I multiply by 10, I get what? Yeah, you guys should know if you multiply by 10, you just throw a 0 out on the side here. Come on, my computer's being slow. Okay, I know that's too big. Got to go a little bit smaller. So I know some of you got, whoops, I don't know where that 9. I know some of you guys might try 44 times 9. You might try 44 times 8. You know, if you want to do that, that's fine with me. Turns out it goes in there 8 times. Okay? 8 times 4 is 32. 8 times 4 is 32, 33, 34, 35. Subtract. Bring that down. Okay? 44 goes into 62 how many times? Once. 1 times 44. Subtract. Okay, I'm going to have to borrow or carry or whatever you were taught to call it. Okay, the tendency is for kids to want to throw in a decimal point and bring down a 0. We're not going to do that. Why? Yeah, they want our remainder as a fraction. So 44 goes into 3,582. 81 whole times, and another how many 44ths of a part of a whole? Yeah, this guy right here goes over the top here, and that becomes your remainder in fraction form. But what do you have to do with this type of remainder? Yeah, you always have to reduce. If you guys don't reduce, I'm going to mark it wrong. Okay? Let's see here. They're both divisible by what? I know for sure they're both divisible by 2. Let's try that. So I get 81 and 9 over 22. Does it divide out any farther than that? No. Can't reduce it any farther. So there's our answer. 81 and 9/22. Okay, problem number 8 is always going to be addition with fractions. If you change these fractions to decimals, I am not going to count it correct. I want to see your answer as a fraction. If I look at your paper, and I always do, if I see you convert them to decimals and then try to attempt to convert them back to fractions, it's wrong, okay? I want to see you do all of your work in fraction form, and you know how to do it. When you're adding fractions and the denominators are different, what do you have to do? Yeah, you have to have a common denominator, okay? Well, let's start with the easy part. Let's add these pieces together. Let's add all of our wholes together. All right, let's do that first. Let's see. 2 plus 3 is 5, plus 1 more is 6. Okay. 3 plus 3 is 6, plus 2 more is 8. All right. Now look at this. A half. 2/3 is bigger than a half, and 7/9 is bigger than a half. So chances are when you put those all together, we're going to have something bigger. I know it's going to be bigger than 1. It might be bigger than 2. It might be a little less than 2. So my prediction is my answer should be somewhere around 87, probably a little bit bigger than 87. Okay? Let's find a common denominator. I have 2, I have 3, and I have 9. What is my common denominator?